Do you wander a lot?
Yes. Yes, I do.
All right, hang on.
Yes, I do.
Is that your range? Oh, come on.
I won't go that far. I'll do my best. It's fine. We'll make it work.
You're good, my man.
Super. Yo, good morning.
Morning.
Yeah, good morning. I just got back from Las Vegas this morning, so I'm running on very, very, very few hours of sleep. I did take a nap today, so yes, did just wake up. So bear with me while I run on fumes, but it should be good. My name is Adam Engebretson. I do all sorts of stuff. I keep myself very busy. I'm a senior software engineer at Adeo Healthcare Solutions. We are a small medical practice management software company based out of Dallas, Texas. I'm also in charge of DevOps. So if any of you are fixing to switch your entire infrastructure to Docker, give me a call. Happy to help. I'm also an adjunct professor at OTC. Student. I see you. Well, thanks for being here. Let's see, I'm also a musician. My wife and I are playing in the pit orchestra for Marshfield Community Theater's production of Annie this summer. And I pretend to be an audio engineer for my wife's band. I turn her up. That's all I really do. I also serve at James River Youth, and I'm a loather of sports and slides. So that will become very apparent when we get further in my slides, so we can see how bad they are. So let's talk about some stuff here. Who's heard of REST? All right, good, excellent. Glad to hear it. We're in the right room. Representational state transfer and why it sucks, right? Now, okay, so obviously I don't think REST sucks. It's obviously served us very well. We all have careers, probably because it exists, among other things, I'm sure. But REST, it's some things I don't like about it. One of them being it's a fixed API. Let's say you sit down and you build out this API, say to manage your blog, and your blog is all front-end JavaScript, so you need to consume an API to retrieve your blog's contents from your backend. And in order to do that, let's say you're on a page and you need to load the categories for your sidebar and the number of posts counts, and you need to load the post contents itself, and maybe also the comments for said post. First of all, we have 3 endpoints we've already talked about. Loading categories with their counts, hopefully that those are 2-in-1 endpoint. Loading the post contents itself, and loading the comments section as well. Those are 3 explicit endpoints. And each one of those are effectively hard-coded. And they expect a fixed set of input and will return to you a fixed style or fixed format of output. And I don't like that. You end up with this very rigid system, and you have these countless endpoints. And I'll define an endpoint as a URI path and an HTTP verb. So even if you have a get/API/posts to retrieve your posts, you might also have a post/API/posts to store a new post. Those are 2 separate endpoints, and you're going to have countless of them in your API. What's hard about this is that we talked about we got these inputs and outputs, and your inputs might be pagination control, something like that, which is everybody's favorite thing to do. And it's a pain because it's up to you, the developer, to I beg your pardon. Bottom left corner is stop screensaver. Excellent. Thank you. Expose. Pagination, right? So it's up to you, the developer, to make sure that throughout your monolithic application, because that's what we build, right? Is you've got all these different endpoints, and many of them support pagination, and it's your job to make sure that that pagination control is consistent across all the different endpoints in your application. That's a pain. Who likes pagination? That's what I thought. The other thing is that all these different endpoints require explicit documentation. You have to do it. Who thinks they have automatic REST documentation? Yeah, didn't think so. Because even if you're using something like Swagger and generating a nice interface, even with an interactive console for your API, you still got to annotate your code or write the Swagger JSON or YAML or whatever. It's still an explicit task. You need to sit down, write your API, define your inputs, your outputs, and then you got to write it all again in documentation form, so that when you hand that API over to your front-end team, they know how to consume it. REST is also designed for CRUD. I read an article today that says we're not storing stuff, we're doing stuff. And REST kind of locks you into this concept of creating, reading, updating, and deleting stuff out of your database or your backend or whatever that may be. REST is designed to kind of support that. Like I said, I just got back from Vegas this morning. My wife and I fly out to Vegas. We hang out with her parents, and then we drive to Disneyland. So I've been at Disneyland this week. And I saw a penny press, and I'm like, that's exactly how I think of a REST API. Fixed input, fixed output, and explicit documentation. 51 cents. You got to put in 51 cents, right? And you have the instructions printed for you. Somebody had to explicitly create this documentation on this penny press machine. You crank the thing, and out you get your penny. It's a very concise, strict API. This is an API. Whenever you interface with something, we're all applications, right? We think like computers, so that's an API right there. It's a fixed input, fixed output. To contrast, GraphQL and why it's better, it's a dynamic API, and we'll see how this comes to play in a minute. But it's a dynamic API. It's not fixed. It's not set in stone. Two users can consume your GraphQL in very different ways and still be interfacing with the same data. They might structure their data differently on the output so that it fits their front end better. Whatever. It's a very flexible solution. And I lied. It's not one endpoint. It's two, right? Because I defined path and verb is an endpoint. You can create a GraphQL request over get or post. So two endpoints. But guess what? It's the same code under the hood, executing your request and serving your response. We also get implicit documentation, meaning once you've stood up your GraphQL server, you don't have to document anything. It's done. It's live. Documentation's there, and I'll show you how that works in a minute. And my boss suggested I find a pizza vending machine, right? Similar concept. It's you're interfacing with it, but you tell it what you want it to spit out. You say, okay, well, I want sausage and pepperoni, small, extra cheese. Put in your money, that's what you get out. The output is mirroring your input. We'll see how that comes together in GraphQL. So what is GraphQL? It's a couple things. GraphQL is a query language for your API. So it's a query language. We just hired, I don't know if Victor's watching, he said he was going to watch, but we just hired this guy from Mexico City, and I've been excited to work with him because I get to practice the Spanish that I learned in high school. I actually learned quite a bit, and I became pretty fluent, but then I stopped speaking Spanish, and now my vocabulary is but one thing that I learned in learning another language, anybody else bilingual, trilingual, multilingual? Yeah. And one thing you learn when you learn another language is that language is just a way of expressing intent, expressing perception, and people do it very differently. And so my favorite example of this is in Spanish. I would say something like tengo calor, which means, literally translated, means I have heat. In English, we'd say I'm warm. It's warm in here. It sure is, isn't it? So just it's a different way of thinking about the world. It's a different way of relaying your thoughts. So language fascinates me, which is why I love GraphQL, because it is in fact a language. It's very expressive. It's a way for you to express your intent, and you get that back. So this query language that we have, I say it's language agnostic. That doesn't really make sense, because the query language itself is just a string. Who knows how to create a string variable in their favorite programming language? Wow. Come to my class at OTC, guys, for real. It's just a string, a series of characters strung together. That is the query, just like SQL. You know, you can create a SQL query just as a string and execute it. It's very easy to consume, and we'll see how that pans out in a few. But it's very easy to consume. It's also strictly typed, which is so useful. So incredibly useful, and it really empowers GraphQL to do a lot of really cool things. It's also super awesome, which is my favorite point. But not only is it a language, a query language, it's also a runtime. And again, language agnostic doesn't really make sense here because the GraphQL runtime is more of it's a spec, right? Anybody found a cool, awesome library like the Matrix real-time messaging library and find out it's only a spec and nobody actually built it? Yeah, that's my favorite. Anyway, so it's just a spec. What's cool about it, though, is GraphQL is so super awesome, number 4, that many people have decided to implement that spec in many different ways in many different programming languages. It's funny, when I agreed with Mike to do this talk, it was 4 months ago, give or take. At the time, I had written a GraphQL API in PHP, specifically Laravel. Since then, I've written one in Node.js, and I've written 2 in Golang, and actually 2 different, completely different implementations of how to do it. It's out there. Ruby? Anybody else? Huh? Yeah, it's dead. Anybody else written a GraphQL API in a different language? I know there's .NET libraries. I know there's C libraries. I know there's Golang libraries. There's all sorts of different ways you can do it. You can do it in any language you want because, again, it's really just a spec. It's dead simple to implement once you get all the vocabulary in your brain. Again, strictly typed and super awesome. So here's a way that I ripped this right off their homepage, graphql.org. Again, I loathe slides. But the first thing you might do when you're going to define a GraphQL API is you're going to describe your data with a schema definition language. Okay, and it's very simple. There's not a lot to it, but we've defined a type here called a project, and has 3 attributes on it: a name, a tagline, and an array of contributors, which are users. This SDL is incomplete. You would also need a type for the user for this to work, but that's just kind of what the SDL might look like. And then you go ahead and send a query. And your query is GraphQL, so this section right here is the GraphQL language. And in this case, we're asking the GraphQL server, hey, give me a project by name GraphQL, and when you give that back to me, all I really want is the tagline for said project. And there's our output, JSON. Bada bing, bada boom. Now you'll notice that the output mirrors the input. And that's what's so cool about this, and that'll come into play. You'll see that more hopefully in the near future. But your output mirrors the input. So this kind of gets back to how the API is dynamic, right? You expose this endpoint to your developers, your front-end people, or even back-end people. I've consumed GraphQL from a back-end before too. And all they need to do is read that implicit documentation, and then they'll know what information they can extract from your API, and they can format it however they want. They can say, oh, I only care about these 2 fields. I don't need all that other data. One of our APIs stores user signatures in base64 encoded pings in the database. Let's not talk about it. But that's a big blob of text. I mean, that's a kilobyte for each signature. So if I'm grabbing a list of users, and there's 100 users, and I want all 100 users, with a REST API, I would get that blob. I'd get that image for every user. So my response would be 100K. That's unacceptable. With GraphQL, you can just say, I don't need that image. I don't need that field, so I'll pass and just ask for the tagline or the first name, last name, whatever. Okay. I recently, don't ask why I'm using Firefox. I will work with Mike to get the link to this repo in the meetup event / in Slack. It's on my private hosted GitLab, so if it's down, it's because I'm putting new RAM sticks in my server or something. And I tried to, my slides are running out of this Golang program, and I tried to get continuous integration to compile a static binary for you, so y'all can just download the binary and run it. You'll have access to my slides and everything. Couldn't get that to work quite yet, but I will. So hopefully by tomorrow, you can go to this repo, go into the CI tab, and download binaries for your architecture, and run this program. You'll have access to my slides as well as the GraphQL API we're going to build today. Cool? Who's built a REST API before? Who's built CRUD? Everybody big cred? Cool. I see my students' hands up. So I have written zero code for this other than my slides. So let's build some crud with GraphQL. What can we crud?
Casinos in Vegas.
I'm sorry?
Casinos in Vegas.
Casinos in Vegas. All right, I can work with that. So let's start by creating our schema.g GraphQL. We'll make this work. Do we need a light theme? Is that better? Light theme better? That's fine. Okay. What information would we store about a casino? What's the very first thing?
Name.
No.
ID.
Thank you. Okay. So we're going to store an ID. Now again, this is strictly type, so we got to give this ID a type. What type should we use for our ID?
ID.
Thank you. ID. That is a GraphQL type. I have found that it really has no significant meaning. It can be a string, an integer. I haven't tried an array or anything like that, but you can use kind of anything you want for the ID. But specifying it as an ID allows your dev tools, especially if you start consuming these APIs from your front end, the libraries in your front end will actually pick up on that and use that for caching. It's so dirt awesome. Cool. So name we said, string. Wow, string. What else? What else do we store about a casino?
Logo.
Logo.
Address.
Address. Let's do this. Wow, I didn't do that.
Really works.
So you see I'm marking these exclamation points. Again, this is the SDL, the schema definition language. The exclamation point means required. We require, or non-null, if you will. So we'll just do this, city, string, we'll call that required state. And zip, we'll call that an integer, it's required. And then let's do one is on strip, Boolean. Is it bool or Boolean?
I think it's cool.
I think it's just bool. Yeah, we'll find out when it fails to compile. Okay, so there's our one type. Let's do one more to kind of go along with the casino idea. Anyone? What should we crud on? Hotel. Good. Hotel. Excellent. Type hotel. And we'll just keep this nice and simple. So we have an ID of type ID, and we'll just do a name. All right, nice and simple. Works for me. I'm actually going to go ahead and add a couple other things here. Let's do a created at as a string. My ORM will handle these for us, so we're not going to have to worry about them too much. But okay, so we have our two types. The next thing we need to do is define one more type called a query. It is the root object of our GraphQL query. Again, remember it's one endpoint. And so there's got to be kind of like this top level item that we work with. So we'll go ahead and call that query. And in this query, I want to be able to do, let's keep it simple. I want to do 4 things. I want to be able to retrieve all hotels. I want to be able to retrieve a single hotel by ID. I want to be able to retrieve all casinos and 1 casino by ID. With me? Okay. So let's do, the way I do this is hotels query. I'm not going to accept any arguments yet, but we'll actually just do hotel. So hotel by ID. Pointers, no, it's fine. So I've defined our first query and how it looks. This is like a method signature, right? If you ever read the documentation for your favorite REST client and your favorite programming language, you've seen method signatures like this, where it's call this method, pass these arguments, get this response, right? And so what we have here is we're having a method, if you will, called hotel. It's going to accept an argument of ID. I need a $sign there, don't Again, we'll find out when I compile it. Of type ID, so this ID argument is of type non-null ID, and it's going to return to us a hotel. I'm also going to do hotels query. It's going to return to us an array of hotels. Okay. Rinse and repeat. Okay. So there we go. This is our SDL. I think this is a pretty good start. We will probably come back and revisit some of this, but the thing is that you can name these whatever you want. The convention I use is hotels query because what I will end up doing if we were to spend more time on this is I would put some arguments in here that allow you to do things like filter by state, filter by if it's on the strip or not, or sort by this, or any kind of arguments you'd want your query to support, I put in there. But we don't need any for now. Who likes Golang? 2. Excellent. Golang is what we're going to be doing today. So let's see how this pans out. What I'm going to do is, now that we've created this schema definition, there's a library out there called GQL Gen. And it's a Golang generator. It's just going to generate some Golang code for us that we're not going to touch. We're just going to consume it. That is going to implement this API for us. So I'm going to have to cd into the correct directory and actually make dir graph GQL gen, pass it the schema file, and of course I did screw something up. Yes, it doesn't like the $sign. Come on. It is Boolean. Thanks for your help. Appreciate it. All right. Look at that. No errors. In Golang, if you're using a Golang command, their idea, their philosophy is that if there's no errors, there's no output. I don't know if I buy that, but whatever. So no output means no errors. So now what we see over here is we've got a couple new files. I'm going to kind of tidy up our files here. We got a couple new files generated. All this junk. I have looked at very little of this code. Don't know what it does. Don't know how it works. Don't really care. How many of you have looked up the C source code definition for like the PHP JSON decode function? Yeah, I have. I don't want to talk about it. But it's one of those things where it's like it's in that black box. Let's not worry about it. It's going to do what it needs to do. But there is one thing that we want to look at here is this resolvers. This is an interface. And also, for those of you who don't know, in Golang, if you have a type that implements an interface, it implements it implicitly. Meaning you do not say, type A implements this interface like you do in PHP, or that's about all I know for programming languages, so I don't know. But it's going to happen implicitly. So what we need to do is we need to implement this interface, and I'll show you that in a second. The other thing that it generated is some models. These are types in Golang. Again, strictly typed. Golang is very strictly typed, which makes it great to work with GraphQL. And this is the type it generated for our casino, and the type it generated for the hotel. You'll notice it looks very similar to the SDL. That's a coincidence, because Golang is smart like GraphQL. So now what we got to do is make our app. And so what we'll do is we'll say, so our app, our GraphQL server is going to be contained in this Vegas app that we've created. One thing that it's going to need is access to my database. Okay, so we'll trust me, it works, right? Okay. So now that our Vegas app will have access to our database, we need to implement those 4 methods. I think we're good with this for now. So what I'm going to do is make it such that So all I've done is taken that interface definition and created the methods, if you will, the functions on our Vegas app that are going to satisfy these different questions we're asking, these different queries. And then the other thing we're going to do is we're going to tell Golang, well, it's kind of weird. It says graph.resolvers Vegas app. Is that going to work? It does work because I did it right. If I said what we're doing here is this line, it doesn't do anything other than ensure that my Vegas app implements the graph resolvers interface, and that's that interface we just generated. So this line of code, if for instance I were to comment this method, I had to do this on my other computer, and I should have done it on this one before I started, but my tools aren't running. It's awesome. This line should be squiggly underlined. There should be an error here because Vegas app currently does not implement the resolvers interface. So let me, it's updating my Golang tools here. Hopefully it'll fix that. But let's take a step. While that's running, the other thing we're going to need to do is add our GraphQL server to our HTTP server. So this is the main entry point of my program for the most part. And what you're seeing here is I'm opening a SQLite database, which is kind of like MySQL, but in a file. What do you do? So we've created our database, and then what I'm going to do is create our app, which is Vegas app, and it needs access to that database. Okay. Did we finish? Are you going to yell at me yet? Hello? Why no error? Oh, I know why. Right. Sorry. You have to import the right path. Love it. Okay. So now that those... There we go. This is telling us, hey, cannot convert Vegas app literal to the type graph resolvers because it does not implement the interface. But as soon as we add this method back, we'll see that we'll get green. Works beautifully. So we've created our back in our HTTP server. I've created my Vegas app, and then we'll go ahead and HTTP handle it. Let's just use GraphQL. You can put it at any endpoint you want. We'll just put it at GraphQL. Nope. Oh, come on then. Like I said, live demo, fingers crossed.
You misspelled make executable.
Yeah, that's why I always copy it, but I was going to be all cool and it didn't work. Okay, hey, the program's running. It at least compiled, so hey, we can go do something there. Thank you very much. Awesome, right? So let's clean this up a little bit. I made a hot mess out of this. We'll just... Okay. So now we've made our executable schema with our app. And this graph.makeExecutable schema thing has been generated for us. And all I have to do is give it one of my apps, and then we can go ahead and run the handler. Now, let's go ahead and hit this. First of all, as you can see, I'm on localhost 8000, and it's my slides. But instead of hitting /static, let's go ahead and hit GraphQL. It worked! Thank you very much. Wow. No operations query because we didn't ask for any data. We didn't give it a query, so it's like, right? Now this is cool, and I can sit here and I can put in a query. I can do, you know, hotels query. Right, I could run that. So I just ran a query. It worked again, but it's not actually returning any data. It's just empty. But this is a pain. Who wants to type weird faux JSON in an address bar? Nobody. So let's make life a little easy for us. I'm going to install the GraphQL playground, and I'll show you how this looks in a second. All we're doing here is we're giving the playground a title, and then the endpoint where our GraphQL server exists, which is just that one endpoint. And I've installed that at /playground. So if we hit /playground, and I wish I knew how to clear my local storage in Firefox, but whatever. So here we go. We get this neat interface tool, and you're like, what is it? The fun part is when we click on Schema, you'll notice that our 4 queries that we've defined are available to us. And we can say, okay, let's look at the hotel query, and it's going to tell us that it's expecting an input of an ID, and it's a required ID, and it's going to that particular query will return to us an instance of a hotel. And an instance of a hotel has an ID, a name, a created at, and updated. Now you might say, oh, well, isn't that fixed inputs, outputs? No. Because if we were to try to run one of these queries, which isn't going to work because we haven't actually implemented our server yet, but if I wanted to, I could say, you know, give me a hotel with an ID of 1, and all I want back from it is the created. See how this is an IDE. This is a web-based IDE for your GraphQL server. Meaning it's not just a WYSIWYG editor. It's going to tell us what we're capable of doing. We're capable of asking for a created at field. But you know what? I want it to be called created on. So I can take that created at field that will be available to us once we actually implement our server and rename it to created on. And my JSON response would reflect that. Okay? Now we'll have to get some data to work with before that makes sense. But I'll run it, and of course, no. Because when I created my resolvers, I just said return nil nil. So there you go. It's working. It's just not very exciting. Okay. Now, in order for our, let's see, do I have a database file set? I do. So let's start this back up again. So there's our empty database file. There it is. Okay, here's our database. No tables. It's an empty, brand new database. Nothing in here. But what I want to do, this is going to blow y'all's mind. Blow your mind. Check this out. Auto migrate. For my students who had to manually write their database migrations, they're going to wish they never bothered learning PHP and instead took Golang because it does it automatically. Okay. All we're going to do is we're going to say, hey, I want you to automatically create database migrations and make my database schema ready for me based on, I need to give it an instance of a casino. So here's an instance of a casino. Migrate the database. Now it just reran my program because I'm watching for changes. It recompiled and re-executed. So if I come over here and refresh, I have a casinos table. Come on! That's so cool! Okay. That's not even GraphQL. That's just the ORM library I found, but it's so cool to me. Let's go ahead and add to that our DB auto migrate Graph Hotel. Okay. So now at least we've got our 2 database tables. So let's go ahead and create a hotel. We'll say it has an ID of 1. Who's got a favorite Las Vegas hotel?
MGM.
I'm sorry?
MGM Grand.
MGM Grand. Create it at now, update it at now. Run it. No. Go. E? No. Save. Oh, that's right. Save. And it didn't work. Yeah, because it created these as strings. That's fine. Today-ish. Tomorrow-ish. That works. Let's just pretend that those are timestamp fields. Obviously, there's a little rough around the edges, but we'll make it work. Now, remember, the query I just ran before was give me a hotel with an ID of 1, and I want created at to be called created on. So we should expect to see today-ish. Now that we have it, oh, just kidding. We haven't implemented the resolver yet. It's still null. Okay, just because the data's there. So let's go implement that resolver. So we're going to pull up our app. This needs to go away. Okay. So the hotel, this is the query we're trying to resolve, the query hotel, which you'll see it's going to accept a context. In Golang, contexts are used for distributed tracing, etc. But you'll see that this method receives an ID. You'll also notice that it's not a pointer to a string, which means in Golang it's required, in short. So we have a required ID. It's going to come in to this method. Let's fetch it from our database. So we'll say our hotel is a brand new instance of a hotel. We're going to say I want to check the hotels table where ID is equal to ID. We'll grab the first result onto our hotel object there, and if we get an error, we're going to return no response but an error. Anybody else worked in a language with multiple return values? It's the coolest thing ever. This function has multiple return values. I love it. So then we'll just return our age. So what we're saying here is we're going to execute our database query. This is it. Boom. Where the ID is equal to the given ID passed in our method. Take the first result that you find and hydrate it onto our hotel object. And if there's an error, return nothing and an error. Otherwise, return the hotel and no error. But I need to return a pointer. Okay. That's cool. Thank you. And you'll notice, too, it's created on, not created at. Even though in the database and in the GraphQL definition it's called created at, we've been able to call it created on, or we just call it C. Whatever. And you have full control over how that data comes back to you. Okay. Let's also real quickly do the same thing here. We'll say our hotel is equal to a slice of GraphQL. Hotel. Same query, really. Come on, then. Graph. There you go. Cannot use pointer to as, oh, yeah. Okay. So now, instead of calling the hotel query, or I'm sorry, hotel, now let's instead call the hotel's query. And what information do we want about our hotels? Name. Just forfeit name. Okay, great. Excellent. Name. Do we want to call it name? Yeah, we want to call it name. It's fine. Ta-da, we have an array of hotels by name. Of course, we just have the one in our database, but there you go. Now, here's the cool part. Run two at once. You can run as many different queries as you want in the same execution. Send both of those questions to the server, and it will respond to you with both of your answers in one. It's pretty cool, eh? So now we got to do casinos, I suppose. Again, we got to... Okay, so that's, again, doing the same thing as I've just run a database query to retrieve a casino by ID. And just to make this nice and quick, we'll go ahead and do it for the casinos query as well. And I just need a slice of those. No where clause. Find that, and you don't want a pointer. Okay, great. All of our queries are now implemented. Yes?
Are there any other libraries that basically auto-generate queries for you, or is that generally a custom? Is that generally code you have to write?
This is generally code you have to write. Here's the thing with Golang is it's a very explicit language. You kind of have to do everything yourself, and some people don't like that. I've grown to like it. It's kind of ironic. Coming from Laravel, I've always loved that I don't have to define the where the request body comes from. It'll find it if it's a multi-part or if it's JSON or whatever. It just kind of does it for you. In Golang, you have to do all of that yourself. It's pretty explicit. So this is using an ORM, which is why I'm not actually typing out queries per se. And I have, what's so cool about the way Golang works is I've created, this is effectively an empty array of casinos. And I give that a pointer to this memory allocation to the find method, and it hydrates this variable. So I didn't say which table to query. It just kind of picked that up by itself off the type. So I think it's easier, but you're right. I know where you're coming from. It'd be nice to say just casino find by ID. Not that I found. This is the only ORM I've worked with in Go. If you find a better one, let me know. How are we doing on time? 7:18. You guys are going to be real sick of me real quick. Again, we can run our casinos query and just ask for IDs. And of course, there's nothing in there. Let's go ahead and put a casino in here so we have something to work with. Anybody know any casinos?
Caesar's Palace.
You know its address?
Not a clue. It's on the strip, though.
123 Las Vegas Boulevard.
Is that really Caesar's Palace?
I don't. It's on Las Vegas Boulevard. Las Vegas, Nevada. I know my in-laws zip code. Don't know the strips, but is on strip. True. Created at a while ago. Updated at later. Cool. Save that into the database. There we go. So now, of course, I can come in here and say, there's our casino. We can ask for its name, address, and if it's on the strip. Come on, is on, there you go. Is on strip, true. And if just for kicks to make sure, because I think, yeah, false, perfect. Now, let's say, let's get rid of our hotels for now. Don't need them. We're just looking at our casinos query. Of course, we only have the one, but let's add the ability to say, I only want casinos that are on the strip. So in order to do that, we need to pass an argument to the casinos query. But this query here, as it's defined, doesn't accept any arguments. So the way we do this is we actually go edit our SDL. And we'll say, I need to Boolean, right? We learned that lesson. You'll also notice I'm not marking it as required. Okay, so when you query this casino's query, you don't have to specify a filter. And in our resolver, we will go ahead and respect that. So I'm just going to go back to my command and just run that generator command again. Bada bing, bada boom. Now, what's funny is that all of a sudden, well, it's in a weird loop, but it won't compile. It's a Golang thing, the fact that it won't compile, but it's because the interface has changed. So if we come look at, let's get this to trigger its build tools again. It no longer implements the interface correctly. So that's why I like having this line here, because it tells you exactly what the problem is. Well, wrong type for the casino query method. It doesn't have the correct inputs. Now I happen to know, because we just added it, that the casinos query needs an is on strip. Needs a pointer because it's optional to the Boolean, and now it'll compile. So that's the only fix we had to make. That's the only change we made to our method signature. to our interface was that Boolean. So now that we've added that there, what I'm going to do let me think about this for a second. We're going to say if that Boolean is on strip is not equal to nil. In other words, if it was provided, then let's go ahead and respect that. I want q to equal a.db.where is on strip is equal to is on strip. I think that's going to work. And actually, there we go. So what I've done is essentially created a query, conditionally added a condition, and then we'll run it. So hopefully that'll work. Oh, yeah, thank you. I heard somebody say question mark too. I'm like, no, don't need a question mark. Oh, you're right. Thank you. So it still works. It's running. I didn't break it too poorly. But now if we say is, oh, interesting. Notice how it's not auto-completing for me? It's just simply because the API has changed. So we'll just refresh, and all of a sudden it will then is on strip. True. There you go. No such column is on strip. Underscores. There we go. Okay, so we get none. If we then change it back to false, we get none. Awesome, right? No? So this is a Boolean where clause, and you know what I think it is that because I just... Oh, that's a Boolean, yeah.
You changed it to false.
I did change it to false, and then I ran the query with a false.
Oh, okay.
I'm still getting null. I wonder if it's just that false type is not... Does it work without it? Did we try running it without this? Yeah. No, let's, when in doubt, check the docs. Where I was looking for a Boolean. Maybe that was a bad example to choose, huh? Since I don't know how to query by a Boolean. Subqueries, that's all cool. Select, order, limit, yada yada yada. Count where. This where method accepts an interface, right? Argues interface is on strip. Oh, you know what? Here. Pointers. I changed it back to true, didn't I? So it's still not working. Don't do that. Don't do that. All right. Well, you know what? Then let's do this. Let's be cool and just say let's filter by state instead. So we'll change this to state as an optional string. Let's go ahead and run my generator. That's going to break my interface, so it won't compile until I change this to state, and it's a string. And we'll just do the same thing. If the state is not nil, then state pointer state running, refresh. Now what's cool is it's going to yell at me. It's like, that's not a valid argument. You can't pass that into your GraphQL query, so we'll say... All right. Something. There we go. At least did it. And if we said, let's look at casinos in Missouri, of course, there aren't any good ones. There we go. So, balls to the Boolean. Okay, cool, right? Now let's do one more real quick. Let's create a hotel, just because there's less fields. We'll do the easier one. Let's add the ability to, through this GraphQL server, create a hotel. In order to do that, we're not going to create a query. Instead, we need to create a mutation. Okay, we'll call it create a hotel. What kind of information do you think is required to create a hotel? Name. Just name. Yep. That's probably required. And that's going to return to us a hotel. Okay. So again, if we just run my generator, and again, we pull up our app, and I trigger that, it's going to say, hey, missing method. So let's go grab that method definition. That's the one. And that should conform as it does. Excellent. So now you'll see that this is accepting a name. Oh, you know. There we go. Let's create our new hotel, right? It's a new graph.hotel. The only thing we know about it is its name. Who has worked with Golang? Just the two of you still, right? It hasn't changed yet? Okay.
Does this count?
Yeah, not quite. It's the strangest thing. I love it. I love this feature of Golang. It's complaining about not having a trailing comma. That makes me so happy. I don't know why, but it does. Trailing comma, fixed. Now, no.
Golang is awesome.
Golang is awesome. It doesn't like this. Anybody know why? Except for anybody who want to take a guess. If you don't know, take a guess. Yeah, Jesse. Huh? Huh? No ID. No. That's not this error. No, it's not complaining about that. Spacing's fine. Syntax is fine. There's actually technically nothing wrong with this code, but Go is like a big dick about declared and unused variables. So it's just declared and unused. So, cool, so let's use it. If error is equal to, we'll call it db. We'll save it. Pass a pointer to it. If there's an error, and the error is not equal to nil, we'll return nil on the error. And then just return hotel and no error. Okay. Pointer to it, of course. So ta-da, we've created this new mutation, and all it does is accept a name. We'll create our hotel object, save it to the database, and then return that newly fully populated object. So I have to refresh to get the new schema, and let's look at it. It's now under mutations here on the right, create hotel. It accepts an input requiring a name, and it's going to return to us hotel. Now this is interesting. This fascinated me when I started working with this. I'm going to actually open up a new tab here. In order to execute this mutation, we got to use this special keyword. It's confusing. It's a mutation. And then we're going to give it our mutation name. Create hotel. What are we creating? Aria. I heard somebody said the Aria earlier. Now, this looks good, but what's so cool about GraphQL is that it's also going to give us back the output. So this is the mutation, and then the output in this object that we're asking for is the hotel we just created. So we can ask for its ID and its name. It's created out and it's up to that, which are going to probably be empty. But it's fine. Let's run it. Cool. I remember running into this issue. Do we have an auto-incrementing ID column? No, there's no auto-incrementing ID column. Okay, so just because I'm awesome. Yeah, cool. type int as, oh yeah. Let's see if that works. Okay, there we go. So it created it. Now, obviously, that's going to break again. If I run it again, it's just going to break because the duplicate key exists. Wait, what? Oh, no, of course. Oh, great. It's not even. Oh, it is saving. Oh, it did save it before, too. It's amazing. So here's, in all honesty, I showed you how it automatically created the migrations. The model, the type that we're using to generate these migrations is the one that was generated by the GraphQL generator, which obviously has no configuration for a database on it. So in a real world, it would be advisable to say, I'm going to create my own custom type that serves as both the GraphQL type and the GORM model that has all the configuration. So we ended up with an auto-incrementing ID on our ID column and primary keys and stuff like that. But that's why this isn't working. And now it can't delete it because it can't figure out how to do it. It's amazing. Wow. They're in there. A little derpy. We got ourselves into a weird state here. But that's the gist of it. Now here's the thing that I want to point out. It's important. Is that in this particular case, we have been consuming a SQLite database to provide the data for GraphQL. It doesn't have to be that way. You don't have to use a database as your data source. You could create a GraphQL interface on top of a series of REST APIs. And in your resolvers, instead of executing database queries, shoot, you can use an in-memory array if you wanted to. You know, your data source is irrelevant. GraphQL has no opinions, zero whatsoever, about where your data comes from, where you store it, and what you do with it. So I kind of like to think of it as like a transport layer. You know, it's really just translating requests into responses for you and giving your front-end people the flexibility to consume it how they want and restructure things how they want. I have slides. I have more. Okay. So we decided to use GraphQL because we ran into a problem. Let me tell you a story. I write medical practice management software. And every time we get a new client, we rewrote our entire software stack. That did not scale very well. And that's the reason being is because we have to integrate with the client's existing practice management scheduling software. Wherever their patient appointment and insurance policy information exists, we needed access to it. And every time we met a new client, it was like, oh, we're going to rewrite it, and it's going to be reusable and flexible, and then it just wasn't, because we were interfacing with whatever application that they had. And every client, everybody uses a different software. So what we ended up doing was creating a suite of microservices called MicroPM, Micro Practice Management. It's 4 microservices, and its job is to serve as our internal consistent API for all this kind of data we need. So we meet a new client. What do? I write a driver that synchronizes the data from their PM into our PM. That way all of our software uses MicroPM and is reusable across clients. All we have to do is rewrite that driver piece for each new client, and boom, they're onboarded. It's a great, grandiose vision, and we're close. But so we have these 4 microservices, and I did all the right things, right? I was so proud of myself. I sat down, I'm like, I'm going to write these, and it's going to serve this awesome purpose. And I did the explicit documentation, and I had consistent pagination, and I had consistent tagging, and I had consistent metadata, and I had consistent all this crap across these 4 different microservices. And I was so proud of myself, and I'm like, all right, ship it. 1.0, tag. Then I sit down to write an application that consumes it. And the very, 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 very first piece or data set that I needed spanned all 4 microservices just to populate the sidebar of this interface. And that's a very complicated thing to consume, to ask all 4 of these microservices for smaller subsets of its data, and I need a subset of persons based on the result of my events query, and then I need to figure out which policies they have so I can load in the pair names, and that was juggling all this crap. It broke down like that because it was RESTful. So we went through this phase where, okay, let's project the current state of these microservices databases into a read-only, or into a document store, like similar to Mongo, but it wasn't Mongo. And then I said, oh, hey, you want to consume these databases? You want to consume these microservices? I'll also give you read-only access to this database. So you can query this aggregation database and get all that kind of stitched together data you needed. Well, that broke down very quickly too, because that database we chose sucked so bad. So, enter GraphQL. GraphQL saved the day, and here's why. Each of the 4 microservices has its own GraphQL schema. Here's one. This is the persons microservice. Here's that top-level query object that we created, and I have persons query, and phones query, and I didn't get around to finishing addresses and emails query, but that's where they go. You see that the person query is going to return to me a person type. Here's what the person type looks like, and this might be a patient or a doctor or a nurse or whoever is a person in our system, but not a user, because that's different. It's microservices for you. So there's a person. Now I want to point out the very bottom value here is meta keys. Remember that. Meta keys is the very last thing you can retrieve off of a person. Okay. Well, then here's the events microservice. We have a places query because it's sort of, this is a paginator, but then here's the place type. And again, I've defined all this in GraphQL. And this is, in fact, GraphQL schemas we're looking at. Events query, and some other stuff to pull all that data. And you also notice that an event type has an array of attendees. I know you can't read it, that's why I was talking so much. An event has many attendees, and an attendee of an event is a person ID and a role. So the events microservice, this is completely isolated all by itself. The events microservice doesn't store persons, but it stores person IDs. Okay? Keep that in mind. Payers, this is insurance companies. We consume it on the third-party API to hydrate our API, stores all of the insurance companies as well as alternate IDs, because payer mapping is the bane of my existence. And then policies. This is the one that stores insurance policies. So I got policies query, and then verifications query, because this also stores, we actually speak with the clearinghouse and say, hey, how much is their deductible and all that. So we're storing that over here in this verification type, right? Remember when I said I don't like slides? So what we have here is we have these 4 microservices, each of them exposing their very own GraphQL server. These are all written in Laravel. Okay? Then I have this bad boy right here, GQL Stitcher. That's written in Node.js, and it's using a suite of libraries called Apollo. They're wonderful. If you Google GraphQL today, you will see an Apollo ad on your Facebook newsfeed tomorrow. It's a promise. The GraphQL Stitcher, what it's aware of, what it's capable of doing is the first thing it does when it boots up, when I deploy that container and start that process, it actually makes a phone call over to persons and says, hey, what are you capable of doing? It introspects this GraphQL server. Okay, then it does this one, this one, this one. So this right now that it's introspected all 4 of those, it knows all of the types, all of the queries, and all of the mutations from all 4 of these microservices. So I can query all of them at once, one endpoint, to fetch all of this data. Cool, right? Only problem is that I still don't have a link between a patient and their appointments. With just these 4 schemas stitched together, all I have is just a bunch of queries that I could go straight to persons for. But there's one other thing that this stitcher does. Oh, here's what it looks like. So this is that entry point query object. You can see there's a lot more there now, and this is just a accumulation of all of the top level queries we had from all four of the microservices. Obviously, now we all have a headache, right? But here's the cool part. If we zoom in a little bit, look at our person type. The very last, what did I say was the last one? Meta keys, right? Now we have events, policies, and unmapped policies. Well, events comes from the events microservice, and policies comes from the policies microservice. Funny how that works, isn't it? But this is a person type. What the GraphQL stitcher allowed me to do was actually say, okay, we have the person type, and that's defined by this person's microservice. But inside this, I've added a couple more schemas on top, and I've said, on a person type, if you want the events, go ahead and just run a query against this microservice, passing in the patient ID. And this one just answers it, just like I asked events directly. Hey, event, give me all the events for this patient ID. But what the stitcher does is it goes ahead and nests that result set inside the patient. I'll show you. I just have to be very careful about what information I show you because, you know, HIPAA laws and I like my job and freedom. Okay. So let's. This is a client. They're based in Alabama. This is their production GraphQL server, and as I showed you that big nasty graph, here are all the different queries and mutations that we can run against this server. But let's go ahead and start by saying, hey, I want events from today. Let's just see how many there are. 545. This particular client is distributed across 22 locations. So there's lots of appointments that they're seeing today. We can also then ask, all right, let's get the ID, the date, actually we know the date. Let's get the time and when the appointment was scheduled. And I don't need the places count anymore, and I don't need the events count anymore. Okay, cool. So now here we have a list of all of the appointments for today, and actually it's page named. So there's 15 of them, but obviously there's more. And we have the created at timestamp, time of the appointment, and its ID. Here's where the magic happens. I can ask for the attendees of the appointment. So we might have a person ID and a role. Each of these appointments should have both a doctor and a patient, because that's who goes to a doctor's office visit. So I have all that information there. Now here's what's cool, here's what's not cool. I can run this same exact query against the events microservice all by itself, because this has not crossed the bounded context of what that events microservice is capable of doing. All of these fields are in the events microservice. But instead of asking for the person ID, what if I wanted the person's social security number? Just kidding. Gender. Let's just pull their gender. Okay, now I just crossed the bounded context of the events microservice, because the events microservice does not have gender in it anywhere, nowhere. Gender is a construct, is a property of a person, which is in the person's microservice. But because the stitcher is so baller, I can ask for all that information. Right there, we have a female patient seeing a male doctor. That's weird. Okay, I can take it a step further. I'm actually going to simplify this and just ask for the patient directly. The patient is the person whose ID is an attendee with a role of patient. Right? It's complicated, but we have patient. We can ask for their gender. Okay. We can also ask for their policies, like hey, how many insurance policies do you have? And we can just get the ID of the policy and maybe the group number of the policy. Okay, I've just crossed yet another bounded context. I'm now talking to 3 of my microservices. Events, the gender, and the patient object, his gender comes out of persons. And then the policies, the ID and the group number obviously comes out of policies. And we can cross it one more time and ask for the payer's name, the insurance company's name. Blue Cross Blue Shield of Alabama. So, not jail. No HIPAA violations yet. Well, maybe I should have that SSN back in there. So this solved our problem, right? I needed, this was like almost exactly, obviously with the patient's name, but this is almost the exact same query I needed to populate the sidebar of the interface I was working on. And do I have, no, I don't have that turned on. I'll show you though. Here's something really cool. Some awesome query. I'm going to go ahead and name this query. This query now has a name, and it's called some awesome query. So let's go ahead and run it. And of course, it's just the same result set. Cool, right? I'm delaying, because distributed tracing is not instant. But let's look at it anyway. There it is. Some awesome query. Okay. This is Apollo engine. Like I said, Apollo, that's the one that'll be on your Facebook newsfeed tomorrow. They have this thing called their engine, and it's baked into their GraphQL server. Their open source Node.js GraphQL server. It's baked into it. And that's what we're using as our stitcher to connect to all 4 of the microservices. When I first spun up the stitcher, it was slow. It was very, very, very slow. Very, 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 very slow. Very slow. It's not so much anymore. Half second, I mean, you know, but it's B2B, so it doesn't really matter, right? So what we're able to see here is courtesy of the Apollo engine, we can actually see how long it's taking to answer each question. So we're looking at the events, and obviously here's data.2, so this is the 3rd event in my array. Obviously, it takes no time at all to just get these properties off of my eloquent model, which is my active record implementation that I've already retrieved from the database. So getting those takes no time at all. But then, when I have to load in the patient, it's actually making a person query to the person's microservice. That takes some time. So it took 160 milliseconds. And you can see through this teardown how long it takes for your queries to execute. So you can turn on monitoring and alerts and all sorts of cool stuff in here so that you can be cognizant of how is your API performing? How are people using your API? How are your front ends performing? Are you getting errors all the time? And it's kind of all just managed right here in this tool. And what's cool is 0 of my data, this much of my data, has made it to Apollo, which is why I can use it, because otherwise, like I said, it'd be a jail. So, and you can see the schema. This is, wow, this is new. All sorts of cool stuff in here, telling us about how it's performing, and obviously this one has run. Oh yeah, this update event metadata, that's running on a cron every 10 minutes. So you can see it's run 4,500 times today. Every 10 minutes per appointment in the next 2 weeks. It's a lot. But I can drill down and I can say, Chris, that query you made sucks. Let's make it better. But it doesn't. It's great. 81 milliseconds. He's done a nice job. So that's Apollo Engine. Also a pretty neat little tool. Thanks. Yeah, it's cool, right? That's awesome, right? That's all I have. Questions? Yes, please.
So I thought when you were looking at the GraphQL documentation, I saw something about joins. So if there's joins, inherent in GraphQL stuff, why do you need a stitcher to tie it together so microservices? Am I just missing something?
I think you're missing something. When I look at joins, that has to do with there's a concept of a fragment in GraphQL. Let's say you have a very poorly structured database. What was you got profiles on colleagues and
all of it. So there's like multiple databases, and they do denormalize some of them, and some of them are
yeah. So what were your types? So you had a colleague and a
profile.
And a profile. What was the other person entity that had a profile?
Yeah. So users have profiles.
Users.
Yeah.
Okay. So a user and a colleague. And he's done it right. He's extracted the profile out, but let's say you didn't. Let's say you have a users table that has Facebook link, Twitter link, and Instagram link. And then your colleague table has those same things. You can extract those out into a fragment in GraphQL. And what that allows you to do is, it's not so much of a join as it is a union. So you can say, different use of the word, exactly. If you're saying, hey, give me a list of things, the GraphQL server could return to you a polymorphic array, and you can say, okay, well, if it's of this type, give me these fields, or if it's of this type, it gets complicated. But there's that join that you're thinking of, that's a very SQL term. Yeah. and there's no database involved in GraphQL. There's database involved in your implementation of it, or in my implementation of it, but there doesn't have to be. Good question. Yeah.
Can you use it with
You're so quiet, Jesse. What?
Can you use it with MySQL?
I just heard you. Amazing. Yes, absolutely, absolutely. Because remember, GraphQL does not care what you do with the requests and where you get the data to satisfy the response. So in my case, we use SQLite. I could very easily spin up a MySQL container and run a MySQL database and just swap out my connection information, and this whole app would work on MySQL right now. Go ahead.
What about Go? Do you have to have Go installed on the server to run it?
No, absolutely not. GraphQL is a spec that has been implemented in many, many, many different languages. I chose to use Go because I'm a very big fan of it right now. Yeah, Ben.
Does the query, does the engine itself allow you to tie into any like header, like authorization stuff?
Yeah. So,
does it live on the context?
Yeah, probably. What I've always done, so I haven't dealt with authentication or authorization in any of my Golang GraphQL stuff yet. But if I were to, I would actually put it as a middleware and handle that outside of the GraphQL server. So I would essentially wrap my GraphQL server in an authentication layer. And from that layer, you could add your roles to the context and then inspect them from inside your resolver. But yeah, that's all available to you because it's still just an HTTP request. So however you pass around your authentication authorization, extract out of the request, respect to however you want. Yeah.
No, for us, we just use an access token, and then we use Apollo, and we just have a middleware, and we store all of that in our store in Vue, and then we just attach those headers as a part of requests, and then that gives us both like server-side rendering and client-side rendering for those requests.
Yeah, I mean the use case I'm talking about is like user data. It's one type of data for all your users, but you don't want user X to user Y.
Oh, you just do that tendency inside of the resolver function.
Yeah. Inside your resolver, you just make sure, is this user authenticated to, just based on whatever conditions that you define.
But the details of the HTTP request come in the resolver.
Well, you get you get arguments in your context. In the context that comes in, you can attach anything to that as a controller for like your API. I'm sorry if I'm.
No, please, yeah, absolutely.
So like at least in like the Ruby sense, like whenever you have a request coming in your controller, it's just that /GraphQL. Whatever's coming in there is like normal stuff. So if you're doing like session cookies or anything like that, you can add to context, and then that gets passed down through the request to all of like the nested fields that you're resolving. So you attach like current user or account or roles or however you're doing your permission system.
And the context in this case was a Golang thing. Do you have context in Ruby too?
Yeah.
Okay. In Laravel, it's just I hook into the global authentication driver, and I can do that from anywhere in the Laravel because I have an IOC container and stuff like that. So however you need to enforce that logic, you have the right to, because at the end of the day, the resolvers are just a function somewhere. And the way Ruby and Golang do that is by passing a context around. But in PHP, it's more global.
In Facebook, they use this concept called data loader and then gen functions, where you use basically you extract these ways to grab the data into a function, and then you pass that to this gen thing that handles the authorization for you.
In this case, I'm in an incognito tab, or Firefox calls it private window, I think. And I'm at that same endpoint. My Laravel application has actually created a middleware that says, I'll allow introspection queries so that this app can pull up this schema thing. But if I run any query here, I'll get a 401. But again, it's just because I did it as a middleware.
explain
Chris,
this.
right?
Sure.
That's what I said. Yeah.
Yeah. You're actually the second person to call me Chris today.
Cheers.
So the top level in your schema definition. Can you explain those like query and mutation? Yeah, are those reserved or? Yeah. Okay.
Guess what? There's one more called subscription. Yeah, WebSockets. Get excited, y'all. Yeah, query. So if I were to start typing in here, hit Q. So yeah, it wants me to type ahead query or mutation or fragment or subscription. There are these top level type definitions that are reserved. But that being said, in your query, your top level query, you can create what it's called a field, but it is the query that resolves stuff. You could have a query. Like at the top level, it's reserved to query, mutation, subscription, and fragment. But inside your query, you can create a query called query if you want to. So like you could have, if your API supported it, you could call it query, and then your consumers again could call it pickle, and then the output would be called pickle.
Would you pull up the network tab and maybe show like a request from like the network perspective? Because I think that would probably that helped me remember.
Yeah. Oh, that's a good point. So this is all happening over AJAX, right? HTTP AJAX calls. Nothing too fancy about it. That being said, there's no reason why you couldn't drive the same functionality over a WebSocket connection or over an RPC or over a raw TCP if you wanted to. You can. At the end of the day, you need to get the query to the server, and the server needs to send the response back. However you do that is up to you. What I'll do is I'm going to close this incognito one. Okay. Here's our network tab. We'll just run it again. And it's about what you'd expect. It's a post request to that URL. It's got my cookie attached to it, so my middlewares can do their thing. Oh, look at that. Thank you, Firefox. So here's the params. Here's what I'll say, though, too, is if you're going to consume it, find a library to do the transport for you. We use one called View Apollo that is so cool, because all you do is just say, hey, here's the query I want to be executed, and it just kind of does it for you. It's just like, here you go, there's your results. And you don't even have to tell it to execute. The tooling's out there to make this super, super simple. Where'd that go? But in this case, it's extracted out the operation name, the query itself, and then any variables. The query as a whole can accept variables that can then be passed as your arguments, and I didn't get into that, but that's the JSON blob of the request, and the response is just what you'd expect it to be. Response. Mike?
Slide this one in quick. Sorry if it was already answered. The playground UI here, is that something that will be naturally found across languages, or is this just goes whatever library you're using implementation of this playground?
Has nothing to do with Golang.
Okay.
Let me take a step back. There's a thing called GraphQL, and if I did persons.sg.rancher.internal/GraphQL, yeah. This is like the official GraphQL editor. It's a node package. You can download a static zip, and you just gotta tell it where the GraphQL server is. It's all front end, all of it. It's 100% static front end JavaScript. That's the official native one. The playground is pretty much just prettier. Their schema pop out is a little bit nicer too, a little less confusing, a little more expressive in my opinion, and the type ahead completion is better. And like I said, it's just prettier. Tabs. Both of them have tabs, yes, and tabs, of course. Both of them have local storage persistence and stuff like that. This is also just a node package, but guess what? It's also an Electron app. Because why not?
Sweet. So they basically, since it's a spec, it adheres to the spec, and therefore kind of works. Awesome.
Yeah, it's just, like I said, just static JavaScript. that makes AJAX calls to the one endpoint. And now, as far as my authentication goes, on this one, I'm accessing it through an API gateway that's handling my authentication from my session, from this login, and yada yada. The authentication here is a freaking nightmare because of the way we have it set up. But there's an HTTP headers UI little thing down here where you can, if you want to just pass in your authorization token, you just JSON right here, authenticate.
What is that history?
About what you expect.
Yeah.
Just letting you see the queries you've run over time. And star queries, and that's another reason why I like the playground better, is it's more of a comprehensive IDE than just an execution tool. Yeah.
I was gonna say, as far as the playground, is that like a library that you downloaded?
It's a static web page with a single JavaScript file, a single CSS file, and maybe some Google fonts.
Have you found?
It's created by the Apollo team on your Facebook feed. You can download the Electron app right off GitHub. You can download a static zip. If you run your server, if you run your GraphQL server with the Apollo tooling, it's a Boolean to turn it on. If you're using something else, however you want to get it in there. I'm doing it right here with this handler library. This is just the maker of the GQL gen people were nice enough to include it for me. So I don't really know what's happening under the hood here, other than that it's really probably just serving those static files up. Anyone else? Thank you very much. Oh, and like I said, I'm going to work very hard. Now that we have data and some stuff, I'm going to probably do some massaging on this and get it tidied up a little bit. And then the plan is, let me show you. This will be the repo. Like I said, Mike and I will get it in Meetup. But if you come into CI/CD here, I will have a successful build where you can actually browse the different binaries. They didn't compile properly, so they don't work. But I'll get them to work. Darwin, Linux, or Windows 32 or 64-bit. Just download it, run it. You might have to chmod it plus X, right? And then run it. And it'll listen on port 8000. It'll tell you that. And it'll create a GQL.db file in the same folder as the executable. That is your database. So if you want to play with it, hit port 8000. It'll redirect you to my slides. Go to /playground, and I'll put some helpful information in there. But you guys can use this and check it out. If anybody wants to learn Go, go get that easy. Super. I'm going to bed. Oh man.